means to explain the nature of planetary orbits. He developed 3 brilliant laws of planetary motion while he was studying decades of precise astronomical data in an effort to find support for his theory. While his 3 laws are still in use today, gravity replaced his theory of harmonics to explain the planet's motions. How did Kepler get part of it wrong? Well, we weren't handed a universal instruction manual. Instead, we continually propose, challenge, revise, or even replace our scientific ideas as a work in progress. Laws usually resist change, since they wouldn't have been adopted if they didn't fit the data. Though we occasionally revise laws in the face of new, unexpected information. A theory's acceptance, however, is often gladiatorial. Multiple theories may compete to supply the best explanation of a new scientific discovery. Upon further research, scientists tend to favor the theory that can explain most of the data, though there may still be gaps in understanding. Scientists also like when a new theory successfully predicts previously unobserved phenomena, like when Dmitri Mendeleev's theory about the periodic table predicted several undiscovered elements. The term scientific theory covers a broad swath. Some theories are new ideas with little experimental evidence that scientists eye with suspicion or even ridicule. Other theories, like those involving the Big Bang, evolution, and climate change, have endured years of experimental confirmation before earning acceptance by the majority of the scientific community. You would need to learn more about a specific explanation before you'd know how well scientists perceive it. The word theory alone doesn't tell you. The scientific community has bet on the wrong horse before. Alchemy, the geocentric model, spontaneous generation, and the interstellar ether are just a few of many theories discarded. But even incorrect theories had their value. Discredited alchemy was the birthplace of modern chemistry, and medicine made great strides long before we understood the roles of bacteria and viruses. That said, better theories often lead to exciting new discoveries that were unimaginable under the old way of thinking. Nor should we assume all of our current scientific theories will stand the test of time. A single unexpected result is enough to challenge the status quo. However, vulnerability to some potentially better explanation doesn't weaken a current scientific theory. Instead, it shields science from becoming unchallenged dogma. A good scientific law is a finely tuned machine, accomplishing its task brilliantly, but ignorant of why it works as well as it does. A good scientific theory is a bruised but unbowed fighter who risks defeat if unable to overpower or adapt to the next challenger. Though different, science needs both laws and theories to understand the whole picture. So next time someone comments that it's just a theory, challenge them to go 9 rounds with the champ and see if they can do any better.
Okay, there we go. Hey, when we met the first time and we were talking about the definition of earth science, I want to make sure, and can you guys hear me as well? I unplugged my mic for the video. Can you hear me better this way? It's like going to the eye doctor. Can you hear me better this way? Or can you hear me better this way? What do you think, Sean?
Go back to the first one.
Okay, I'll take the headset off. I've heard that before. Okay, so earth science includes environmental science. It's one of the hottest majors, like transferring from Vincennes into Purdue's BS in environmental geology. That's a great track. And natural resources, we're the natural resource environmental science department, and we have agriculture and horticulture, and it all comes under the umbrella of geos. And we're basically the department, we're the outsiders. That's what I call our department, the outsiders, because we don't like being in a chemistry lab or a biology lab. We like to be outside. We like to be at Robeson Hills. We like to take field trips. And I think, are all of you guys physically located on campus or close enough that if we wanted to meet and do an outside field trip, we could do that?
Yeah.
Anybody that's in section 003. That's awesome because the USGS
Yes.
will come down and, all right, cool. Because Paul Baker from USGS in Indianapolis, they'll come down and they'll check the stream flow, the discharge of the Wabash River, and they have a stage, a river stage gauge there. And they're supposed to come down like third week next month, and I'll let everybody know. And when they come out, I'm going to invite you guys all to meet me at the bridge so they can kind of give us a tour. It's neat. They show up with their John boat and waders, and they go out and they check the depth of the river, and they check the discharge, the flow of the river. And then up on the Memorial Bridge, they have both a digital river stage gauge, and then they've got the old-fashioned that you crank out to see what the elevation of the top of the river is. And they've also got a digital rain gauge and the digital flood stage gauge up on the bridge. They're like these boxes. If you guys cross the bridge, like don't have a wreck or anything, but there's a walkway across Memorial Bridge, so we can single file up there, and that's pretty cool. So I'll let you guys know about that because we like to get outside. And then people influence these earth processes, okay? And again, earth systems are like the hottest topic, talking about the earth, all of these systems on the earth and how they interact. And I'm into GIS and GIS mapping and making maps, and so I love to have a map that's got about like 6 different parameters on it, and you have to read the legend to figure it out. Does anybody know what my favorite mineral is? Not my favorite rock, okay? My favorite rock is limestone. Well, it's either coal or limestone. I like them both really well. But my favorite mineral is a pink, unheated, natural sapphire from Madagascar. I like it so well, I thought about flying over there to get one. And so on my slides and stuff, I like to put things that I like about geology, and I love geology. I've loved it since the first day I sat in a class. But in your book, 1.3, section 1. It's in section 1.1, and they talk about geologic time. Okay, and we've got the 4.6 billion years old, and it's super long time. It's a span of time it's really hard to get our heads around. And because we're used to dealing with like hours, days, weeks, years, but we're really not used to dealing with, 1 million or a billion. Okay, so this magnitude of time is something that the book on page 8, this is one of the smart figures. So if you go into your e-text, there's actually a video that accompanies this. And basically, they have shrunk all of geologic time into 1 calendar year. Okay, and then they start 1, 2, 3. Can you guys see my mouse as I come around this? 4, 5. And the point being that if all of this Earth business in the solar system started on January 1 of the first of this theoretical compressed year, you'd have to get all the way to late November before you see any plants or fossils of animals in the rock record. And what they're talking about is when we talk about geology, we talk about the geologic time like a book. And so the oldest rocks at the bottom, okay, as you start coming up the different pages in the book, if you had a book, you would find the fossils in the layer at the very, very top of the book. If you've got a book, like if I take your textbook right now, I've got it set on the table, right? The oldest rocks are at the bottom, closer to the table. The younger rocks are at the top. And at the very, very top of those layers in this rock is when geologists have found evidence of life and these fossils. And has anybody in here seen a fossil? Anybody in here collected a fossil? Anybody got a fossil? Caleb, you got a fossil? Bryce didn't have a fossil. Sean, you got any fossils?
No.
Oh man, it's bad. Are you guys kidding me? You don't have any fossils?
My connection just timed out. I missed about 30 seconds of what was said.
Okay. Let's look at a fossil real quick, man. This is crazy. They're telling me. Okay, so this is a crinoid head.
Mason
You got
said
what?
he has one at home.
Cool. Mason, what does it look like? Do you know if it's a plant or an animal fossil? Let me know what he says, but right here, I just Googled crinoid Bloomington, Indiana. Here's a crinoid head up from Lake Monroe. When I was a student up there, we just go out to the lake. Here's some Indian beads, they call them. Anybody seen these things? They call them Indian beads because the Indians would collect them, wear them as a necklace. You can get those out at Paintown in the limestone. Here's a Rugose coral straight out of the limestone. There's fossils all over. I went up to Park County, got some shark teeth out of some black shale. I don't know what your high school teachers are doing, but they ought to be producing fossils. So Mason says he thinks it's probably a brachiopod. Here's an intact crinoid. These are like ancient, they're like sea anemones. I've never got to find like the actual head of it. I was on a field trip and another student found one. It kind of ticked me off. So Indiana, I mean, the rocks are packed with fossils. My favorite invertebrate fossil is trilobite. And I have found some of those. They're like these ancient little cockroaches. And they're really cool. And you can, let's see, they kind of scurried around, and you can find those. Those are in the older rocks in Indiana. And then Indiana plant fossils. We have some outstanding plant fossils, Calamites, Lepidodendron. We have wonderful fern fossils out of Knox County. I went down to the old April mine and collected some of these fern fossils. Here's some. I don't know if Mason, if yours looked like this. He's left. But we have some world-class fossils. If you go to McCormick Creek State Park, you can ask them to see some of their plant and animal fossils. Here's some wonderful fern fossils. They're packed. You come into the coal mine, even up Bear Run, some of the underground mines. We have just entered from Illinois. They have some world-class plant fossils. The Pennsylvanian, you go underground. I mean, we have fossils everywhere in our rocks in Indiana. It's just an absolute joy to even talk about and look at them. But back to this geologic time deal. So the point being is, in the rock record, we didn't find any of these fossils until late November. All right, they had to blow up the month of December because we're all shrunk down, And then basically what it's showing is dinosaurs dominated in mid-December. Okay, in this rock record is geologic history, and all we know is if we find a fossil, and then you're putting that together. All right. We don't know what we don't know, and we can't sit around and argue about the things that we don't know. And it's not even worth talking about because we're scientists, and we only need to discuss what we have evidence for. So don't ever go down that rabbit hole. And then, so what it tells us is that the Ice Age glaciers, then they blow up the last day of the year. Christian, you want to try connecting with your phone, and I am recording this. So if you disconnect, don't worry about it. But try connecting to your phone with a hotspot, or I don't know if there's if you can move to a different spot. But anyway, just do the best you can, or watch the recording. I'll get it posted for you. And so basically, what this is showing is at 11:49, so almost midnight, is when the rock record and the humans show up for the rock record. Okay, I mean, and I'll tell you this. This is what the book puts, but let me tell you what Dr. Brophy had us do up at IU. If you're up at the IU Geology Building, right now it's under construction on 10th Street. It's a long, skinny building. I would say that thing is about 200 to 250 yards long, frankly. It's really long and skinny. What he had us do is take these long strips of paper, tape them together, and lay them down on the floor down that hallway. And what we did is we scaled out whenever the first fossils were found, and we made a mark. And keep in mind, we started out on the east side of that building. And when you walk down that hallway as you're going west, and right before you turn the corner is the elevator, okay? And right before we turned the corner is where we put the mark where they found Homo sapien fossils or whatever. So it's like right at the end of the rock record. So it's just it's just this vast amount of time. And we just put it, it's hard, we just, and the best that we know is it's in human years, okay? As you put together the evidence and the dating of the rock record and using zircon and those type of things. So that's our book's way, using shrinking time to help us understand the magnitude of geologic time. Now, when you look at this, the 0 on the right is the present. Then we go back in time to the 4.6 billion years, and this one happens to be in million years, so they've got 4,600. So it's 4,600 million years, which is the same thing. You move the decimal 4.6 billion years. You guys are doing that math. But this shows in purple what they think the CO2 levels were in the purple line, and what they think the delta T in degrees Celsius temperature was in the kind of, that would be a turquoise colored line. And the point being, we're up here at ground zero, time 0. So things have been much different in the past based on proxy data from ice cores and from, we know that there were these BIFs, these banded iron formation rocks early on, like on that in the Cambrian, we find those BIFs. We know those rocks could not have formed on top of the ground if there was a lot of oxygen, because they basically would have rusted away. So those BIFs, those banded iron formations, we got some great BIFs in Missouri. You can go see an outcrop, or up in Canada. We use the proxy data. We weren't around, right? Because we're way up here, in the Quaternary. And then notice this has at the top, this is like the geologic time scale, the book laid on its side. So the oldest books are on the left, the oldest rocks, and the youngest rocks are on the right. So you got the Precambrian, the Paleozoic, then the Mesozoic. Those are the dinosaur package. And we do not have that package in Indiana. We do not know if they were here and the rocks got eroded away, or if they just never tracked this way. We don't know what the deal is. Maybe we were kind of underwater at the time, but for whatever reason, we do not know why we don't have any dinosaur rocks in Indiana. And then you've got the younger rocks. So then we talked about the nature of the scientific inquiry, how we kind of unlock the secrets of Earth. We know that science assumes the natural world is consistent and predictable, thank goodness. And our goal as scientists, all of us, you guys, is to discover these patterns. And I always tell my interns, my geologist interns, expect what you see and see what you expect. Expect what you see and see what you expect. Andrew Smith, he's one of the other geology instructors. Last week, he was sitting on Highway 41 at a stoplight, I think somewhere around Princeton, on Highway 41. They must have been north of Princeton, I don't know. But he looked in his rearview mirror, he saw a truck, a semi, coming up, and he noticed he wasn't slowing down. And thank goodness he was in his lane behind him. And thank goodness at the last minute, he kept watching. The trucker went into the other lane and basically blew through the light. Now, Andrew was expecting what he was going to see, and he didn't see what he expected, so he was able to kind of pay attention. He could have gotten into the, off into the median to get out of that trucker's way, and thank goodness the trucker went in the other. But all through life, you want to expect what you see what you expect. When you don't, then you know there's something different about the pattern. And I think some farmers now are wondering, about all of this rain. We've been getting a lot of rain. So just a simple idea, it can become a hypothesis or a question, and then we test it as a theory. Then something becomes a paradigm. And does anybody have any example of what they think a paradigm would be? A paradigm meaning a theory that explains a large number of things that are interrelated. Anybody have an idea or an example of a paradigm? What are we getting there on the chat?
I'm not seeing anything.
Do what?
I'm not seeing anything.
I thought I heard something, but maybe not. So, is there anything to you guys that, it's like an example of a paradigm?
Evolution.
Evolution actually is a theory.
Bryce said Stonehenge.
And I'm glad. Okay, I gotta see who is, because I threw this out. Who said that?
The Stonehenge?
Who said that? Yeah, who said Stonehenge?
Bryce Ross.
Okay, Bryce, because now your mic's off. But okay, so I'm glad the regular lecture didn't say anything. But normally on campus, when I say paradigm, I get something like Stonehenge or some of these kind of funky things, these patterns that that I don't know. There was another one that a student gave me. But I'm glad that you kind of brought that up. And sometimes there's some of these non-scientific ideas like creep in, okay? But when they're talking about paradigm here, they're just talking about scientific theories, okay? All right, the scientific method, you're going to gather facts and formulate the hypothesis and theory. And I'm just leaving this up because it's in your book, okay? This is the diagram in your book. This is the one you want to use and get to know for your midterm. So the steps are raise a question. So the hypothesis is the question. Do your background research. Construct the hypothesis, okay? Do a little bit of background research on it. Then you develop it and you create an experiment, and then you start to analyze the data. So you put the data in an Excel spreadsheet or some kind of computer program, and then you get your results. And then you have to discuss what results supported your hypothesis, what only partially supported it. Then you have to write it up and take it to a scientific meeting, and they're brutal. Let me tell you, they're brutal. I saw Dr. Firm one time. I was at a meeting, and God rest his soul, he's passed away now, but there was this guy giving this talk claiming that there had been all of these storms during the Devonian. And Dr. Firm rolled his cigar in his mouth and pointed out that how he waited for the whole presentation to be over. And I looked at somebody, I go, he's getting ready to nail that guy. And he starts rolling his cigar. It's never lit, okay, but he would roll it at this meeting. And he goes, since we have the most amount of plant fossils during that time period that you're speaking about, how is it that that there would be all these massive storms? How would we have intact plant fossils? And pretty much the guy had worked on it for probably 5 years, and Dr. Firm nailed him just with one question. So the evolution of early Earth. Now make sure you hit this. It's only a couple pages on page 13, and it says the universe started with the Big Bang. That's the best we know. We're still using the Big Bang, and we meaning the astrophysicist, okay? So the Earth and the other planets essentially all formed at the same time is what we believe, based on getting hunks of the moon and hunks of these different planets, and then like also by with our telescopes kind of measuring what they're emitting in the gases. And the whole solar system basically evolved, they think, from a gas cloud, okay? And it was so, like, from the gravity, it kind of like, it collapsed under its own gravitation. The universe is made of mostly hydrogen and helium. Our sun's a big nuclear reactor of hydrogen and helium. And we know that the inner planets are mainly rocky, where the big ones, the larger planets, are more gaseous and icy. So in the book, our Smart Figure 1.9, the nebular theory, and you're going to see that on your quiz, you're going to see that on the midterm and the final. So you've got what they think, and these are astrophysicists, okay? This isn't like geology. We're getting this in earth science from the astrophysicists. And it all starts with that nebula gas cloud. It contracts and flattens, and then the disk is formed. The sun's in the middle. We're heliocentric, all right? And, Galileo was put in prison by the church because he thought that we were sun-centered whenever they all thought we were earth-centered. He actually got put in prison in his later life. And then you've got our whole solar system there, the sun in the middle. We're the third rock from the sun. All right, now, if you get in an airplane, okay, how long do you think it would take you in days to get to fly around the equator? So how long will it take to fly around the equator? And I have to give you the speed, if you are going 620 miles an hour. You guys think it'd be 1 day? Think it'd be 1.7 days? Or you think it'd take 3 days? And I'm going to start a poll, and let's see what you guys answer. So if you get in a plane, the equator is about 24,901 miles, the circumference to get around it. And so if you're traveling about 620 miles an hour, which is 1,000 kilometers an hour, how long is it going to take you to get around? And I know it may be hard to read. Zoom into that. And this is what I do in class a lot, just to make sure people are awake. I'll paying attention, we'll get it. And so we've got 6 people that haven't responded. Let's see who they are. Let's see if they went to watch the news or something. And let's see, DeAndre, I don't have a response from you. I don't have a response from Jonah, and I don't have a response from Sean or Zachary. There goes Sean. He popped. DeAndre popped. Jonah's there. So the only person who hasn't responded is Zachary. And I hope that the people that are putting 3 are looking at the slide and reading it. And I'll probably do this, about every 15 minutes. Looks like Zach's totally zoned out on us, or at least he can't hear us, or I don't know what the deal is with Zach. Sean, can you send it to chat? You're able to chat in the chat room, right?
Yeah.
So why don't you put in there, hey Zach, are you there? Can you hear us? Right, so that's pretty good. We've got 13 people that have read the slide in the number 1. It says to take a jet plane. And Ari, I appreciate that. It says it did submit though. I've got you. I have you. Let me show you guys what I see. Can you guys also see who votes on a poll? Sean, can you see what I'm seeing?
Yeah, I can see what you see.
Okay, cool. I don't think I said your name, Ari, but who knows? But if Zachary is who we were trying to get a hold of there.
I sent a chat to him.
All right, cool. I appreciate that. So these are just some quick facts I put together for you. We're an average distance from the sun. Now, I have another question for you guys. Do you think that we are closer to the sun in the summer or the winter, as far as our orbit path around the sun? Do you think we're closer to the sun in the summer or farther from the sun in the summer?
Closer.
Yeah, intuitively you would think that, but that's not right. Or wait, yeah, we're farther. We're actually farther. We're at the aphelion. We're farther from the sun in the summer. Okay. Now, any ideas? If the orbit is almost circular, but it's a little bit elliptical. Are there any ideas? Turn your mic. Let me know. Why do you think then that it's hotter here in the summer?
Don't seasons have to do more with the tilt of the Earth? The closeness to the sun?
That's right. And we are time about 23.5 degrees, right? So what that means is that in the northern hemisphere during the summer, we're tilted towards the sun. And that explains why in the southern hemisphere, Australia, that's their winter, right? So in our summer is their winter, because then, okay, as we come around the sun, then in our winter, we're tilted away from the sun in the northern hemisphere, and then they're tilted towards the sun. So whenever let's say, okay, well, I'm going to go visit Australia, annual temperatures. I want to go to all. Let's see. Average temperature of Sydney. Okay, and this is what Google gives you. If you guys check this out, you get a graph. Now check this out. So here are the averages for January through December for Sydney, Australia. It's colder there in the summer, right? So conversely, let's do annual Australian temperatures by month. I don't want that. Let's do, where's somewhere cool in the northern hemisphere you guys would like to go? Any islands or anything? Let's go to Cancun. Average.
Norway.
Norway. Hold on, we'll go to Norway, but here's Cancun. Look at their graph. It's the opposite of the Australia graph, isn't it? It's warmer here in the northern hemisphere. You got the highs, you got the lows. Did he say Norway?
Yeah.
Norway average temperature. Do you know a city there? If you don't put in like an actual place, but here's one of their climate graphs. So here's Virgin, Norway. That's in Celsius, which I usually need Fahrenheit, but that'll work. And here's the Virgin Sea. So definitely warmer in the northern hemisphere, right? On their climate graph. So I just want to point that out, that's kind of a funky thing that, you know, we're farther away from the sun in the northern, or in the whole Earth, is farther away from the sun in the summer, but because of the tilt, that is the correct answer that you made there. Now, I want to tell you, right now, and thank goodness, I've had a lot of speeding tickets in my life. I don't have any points or anything now, but back in the day, I mean, like I had just got my license. I got a speeding ticket coming down highway. I think I was headed into Newberry, my hometown. But you guys right now all need to be given a speeding ticket because with this Earth spinning like it is, you're going about 800 miles an hour right now. We're about 38 degrees latitude. So I just want you to be aware of that. I'm not the only one that needs to get a speeding ticket. You are too. Now, let's see. What are the 4 Earth spheres? You guys need to put this in your notes and you need to know it. It's obvious that the ocean covers the Earth, 71% of it, right? It's everywhere. So the first sphere that you need to know on Earth is the hydrosphere, okay? Now check this out. If you have all of the water and you've got it in a cube, okay, that's the hydrosphere, all water. Out of the 71% that's water, this is just water. 96.5% of it, water is in the ocean. It's salty, okay? 0.9% of it is salty groundwater, okay? So that big box, all of it's salty right here, except this little bitty box. 2.5% of all the water on Earth is fresh, but only 0.03 is on the surface. 0.75 of what's fresh is in the ground. 1.72% of all that fresh water is tied up in a glacier. So we just have this tiny little bit of fresh water, and we need water as humans, right? So it's 3/100 of 1% are the streams, the lakes, any kind of soil residual moisture. So that's why we have to protect our water resource. It's super important to know what watershed you live in, to be aware of what factories, what discharge going on there. I have a well, it's a cased well, so we really need to take care of this fresh water. And we have more water here in Indiana, Ohio, because we're close to the Ohio River. But if you lived in Arizona today, you wouldn't be watering your lawn. You don't get to mow. You don't even have a lawn to mow. It's just like my buddy who lives out in Santa Fe, him and his wife, you drive up, it's really nice. They don't have to mow. It's just a bunch of rocks, right? And if you start watering something, your neighbors will come out and like shame you, right? If you play golf, it's like the golf courses have to have all these elaborate recycling the water resources because they're really low on that resource. And it's the newest resource. Water is a super hot topic. It's such a hot topic that the Indiana Geological Survey changed their name from the IGS to the Indiana Geological and Water Resource. I don't even know what it is. It's IGWS now. Okay, the second one is atmosphere. It's just this thin blanket. When you guys walk outside today, if you're looking out a window like I am, it goes up about 3.5 miles, our atmosphere. Okay, you walk outside, it's layered. The first layer is the troposphere. You walk out in the troposphere. Now this is a cool graph. It's the kind of graph I love in geoscience. It's got about 3 or 4 things going on. Air pressure on the x-axis, 0 to 1,000, and in millibars. And Mount Everest is 29,035 feet high, And so the air pressure on the ground, we're about 1,000 millibars, it goes down to 314 millibars. So there's not much air pressure, difficult to breathe. If you get in a plane and you fly to Denver, like I do every February for a mining engineering meeting, and you land, you don't feel so good. I forget, I'm at elevation, I think 5,000 or 6,000 in Denver. Somebody can Google that, I don't know, but to see what the elevation is in Denver, Colorado. The first day I don't feel so well, but then I start walking around. The second day I'm feeling better, the third day I'm great. When I get on that plane and I come back on the fourth, fifth day, I feel like Superwoman because, man, it feels great when you go from high elevation to low, like you just, just oxygen and the pressure, you just feel great. But that's why when you release a weather balloon, we release one there on campus. We probably do it in October, and it's got a computerized sound on it, and we inflate the balloon. The engineering group, the students do it, and then I always invite all of the earth science people so they can see our weather balloon, and you can track it with your phone app. And the first year we did it, we were afraid. We had a GoPro on the weather balloon, and we were afraid it actually went east all the way, and it almost got to the river, but thank goodness it landed in a farmer's field. But the reason why the weather balloon, you inflate it, and then it goes up, and it went up above the tropos pause, then the air pressure is so low, the balloon expands and it pops. And so you get your readings of pressure, wind speed, temperature going up, and then you get it down when the sand falls to the ground. So we just have that shallow layer again, less than 4 miles. The third sphere is the biosphere, which is weird. Biology is not a part of earth science, but then we talk, thank you, 5280 is what Sean said for elevation at Denver. Yeah, I think that somewhere around 5,000, 6,000 feet. And sea level is 0. Okay, so it's 0, and then if you travel in your vertical direction above the sea level, so he said Denver is just a little bit over 5,000 feet above mean sea level elevation line. So the biosphere includes all life. It's concentrated near the surface because we don't have many critters like just living up in the air there. And it's a zone that extends from the ocean floor upward. And I could really disagree with this because, there are some critters that kind of drill down into the ocean floor, but I'm not going to disagree too much with the authors. But you get their point. Bottom of the ocean to just where some of the critters get into the air. So the biosphere includes the tropical rainforest, and then this photograph on the right are microorganisms, tube worms. These are the seafloor spreading centers where extremophiles live. It's really cool. Now, the fourth sphere, my favorite sphere, the geosphere. It's solid Earth. It extends from the center, from the surface down to the center of the Earth. It's the largest of the 4 spheres, so make sure you know that for the midterm. It's based on different compositions, the crust and the mantle. And there should be a cut right there. I need to move that slide up. So what you've got is the inner core and the outer core. The inner core is solid from what we believe for seismic soundings. We detonate, and then we have geophones on top. And then you've got an outer core that's liquid, both iron and nickel. Then you've got the mantle, which is composed of the lower mantle, which is solid, and the upper mantle is solid. But then you blow that up, all right? And even though they have solid for the upper mantle, that asthenosphere is a little bit ooey-gooey, okay? But then the lithosphere, the very top, the crust, the oceanic and the continental crust, all solid, rigid. It's about 100 kilometers thick. So those are the Earth's layers that's talking about, okay? Now, real quick, it's 10:30. We go to 10:45. Has anybody had lab? Does anybody not have lab? Does anybody having trouble with lab? And in lab, you're doing metric system and a bunch of zeros. Do we have any comments about lab at this point?
I have lab today at 3.
Okay, is your instructor Andrew?
Last name Nettles.
Oh, you've got Chris. Okay, so you've got Chris. So both of them are great. And basically, number one, what you need to do with that lab manual, let me pull that over here. So you guys are going to do the metric system chapter 1. You're on page 1. It'll give you the list of objectives, and it says you're going to list the metric units, you're going to convert units, you're going to understand and use micrometers or nanometers. I had a complaint. They said that the base unit or the little graph on page 3 didn't include nano units. And then you're going to conduct scientific, you're going to basically drop a rock into, some water and see how it displaces the water. The first thing before lab, you need to make sure you read page 1 and do your pre-lab video. And the pre-lab video, I'm going to put that in the chat. You can either scan it with a barcode, or you can go to this website, and it's on the front page of your lab. Darn it. So you go HTTPS and go // I don't know why it's doing that. It doesn't like my // okay, and then goo.gl /TXRE7A. So let's try that. Let's see what happens. So that should bring up the pre-lab video. I'm not going to watch all that.
Hello, students.
And it's got closed captions, so you can turn your closed caption on.
Lab, we're going to be taking a look at the metric system.
I usually turn my speed up because I have no patience.
Measurements of mass and distance.
But each week, I would recommend you watch that pre-lab video before you go in,
That might be better expressed.
and it'll kind of tell you how to
We can
convert
also go
stuff.
from gallons to liter.
Okay. So I just want to point that out, and I emailed you a couple videos. I would watch the King Henry the chocolate deal that I sent you, and I'm going to set that aside. And the lab next week you'll have a pre-lab. You'll do your pre-lab, that's why you need that Pearson code. And so you watch your lab video, do your pre-lab, you come to lab, and then you do the lab, and they check off and look at you've done it, and then you've got some post-lab questions that you post up on Blackboard. So that's 30 points each week. It's 10 for the pre-lab, 10 before you leave the lab, and 10 points on your post-lab that you do on Blackboard. So is everybody cool on how to convert? And here I just want to point out again, whenever you're doing conversions, if it's not your bailiwick, if that's not your strength, I want you to always go back to 1 foot equals 12 inches. I want you to go back to that, all right? Because if I say, okay, if you have 12 inches, tell me how many feet that is, all right? And do a reasoning check. You know that the inches are going to be bigger and that the foot is going to be smaller, right? So go back and convert from inches to feet, and then have that clear in your mind. You guys can understand what I'm saying? They're just doing a reasoning check. Can you guys see a blank screen?
Yeah.
Let's see. So what I'm saying is, you've got 12 inches, and that's what you are given. So that's your given. What you want, and what we want is feet. Okay, so we have to put, I call it the washing machine. We need that washing machine converter in there. And what we know is, and feet are on top. So we know we've got feet on top. And so how many inches equal a foot? 12. But that's what we were given, and we want to get rid of that, right? We want that to go away. And so it does, it cancels. The 12 and the 12 cancels, so we know we were given inches, and then we put it in the conversion washing machine, so 12 inches equals 1 foot. And always do the reasoning check. If I give you centimeters, and I want you to convert that to kilometers, reasoning-wise, we know that this is going to be a big number, and that's going to be a little number, right? So whenever you're converting, always just do that reasoning check in your mind, right? Because with the metric system, you're just moving decimal places all the time, okay? And then here comes screen 2. And always also remember, which I always share that, whether it's right or wrong, but if I want to go I want to go 12 inches equals how many feet? You guys hear me?
You're back.
Oh, thank gosh. I don't know. I
Yay.
All right. Here was my point. If the Google calculator, 12 inches equals how many feet? Look at that. It comes up. Is that not awesome? And then you can put 24 inches equals 2 feet, and 48 inches equals 4 feet. I mean, I love
Can
the
we
Google
use that in lab?
Probably he's gonna. No, they actually want you to actually do it by hand, but I want you to be aware because you need to know how to do it by hand. But I also want you to be aware of this Google calculator also. Okay.
Okay.
So when I was sharing the screen, you did see me actually do a conversion on the screen. I hope. Did you hear the washing machine comment?
Yes.
Okay, good. And,
Yeah.
But just be aware of it, okay? It's really cool. All right. So, are there any questions about lab? Do we, at this point right now, does anybody have any lab questions or code questions? We got 2 classes and 2 codes. You're going to get a grade for the lecture. That's 3 credits. You're going to get a grade for the lab, and that's 1 credit. All right. They are decoupled.
So after we watch the video for the lab, is there a test with the video?
No,
Okay.
but if you look in Blackboard, let's pull that up and take a look at that. If I can get my cursor back, and I'll try not to turn that off. But let's go to lab. Or I don't have a lab. I'd have to, because I normally teach a lab, and I'm not teaching a lab this semester. But let me think about that. You should have in your lab section on Blackboard, you should have a study area. And once you get your Pearson code registered, you should have everything that we have. Like, so, you go to Pearson My Lab, and has everybody clear on how you register for this class, that you don't need a class ID because you do everything from within Blackboard? Everybody clear on that? I'm going to put this on student mode. Let's see what happens here. So the first time that you come into Pearson, you can click on any of the links, and I've already registered as a student, so I can't go back through that again. But the first thing it'll do, it's going to prompt you to log in, to make a Pearson login. So you got to do that. Once you make the login, it'll come up and say, do you have an access code, or do you want to buy an access code with the red arrow? For lab, you need to ask Chris, but for lab, the only option when you register is the access code, because you buy the lab manual in the bookstore and the code's inside. So for the lab, your only option is to register the code on the left, okay? For the lecture, you do have a choice. You can use the one, if you buy a code at the bookstore, the cheapest option is to buy the ebook with the My Mastering, the $79.99, or the third option is the 14-day temporary access, okay? So there's no excuse for anybody to be able to not take their reading quiz next week, because you could do the 14-day trial. Now, if you expect that your financial aid is not going to come in, don't register until next Wednesday. But as a student, once you get registered, I'm talking about the lecture, this is what you're going to see. And right now, you've got an extra credit due tomorrow night, Introduction to My Mastering. And you also, there should be a dynamic study module.
Yeah, I think it's down toward the bottom.
Yeah, this one I can go ahead and do. Now, make note that these are the reading quizzes. These are the 12 reading quizzes. Your first reading quiz is due next week. Looks like we've had a couple people take that. These are worth 20 points, the RQs, the reading quizzes. So those are due every Thursday night at 11:59 p.m., okay? So worst case scenario, if you don't want some of that extra credit, don't worry about it. I think it's probably 7, 8 points. This week, you could register, you could do the 14-day trial like Wednesday of next week. The dynamic study modules are only worth 2 extra credit points, okay? They're always available to you. They're all due on December 1st. The other extra credit, I've got chapters 1 through 13. You can see those. You'll see more up here. And those are all due December 1st. Okay. Now, the way this class works, you've got to do the reading quizzes. You don't have to do the extra credit, but if you do enough of them, if you get to your points at 503, then you don't have to take the final. Okay. I don't care how you get there. And you know, they have all kinds of different activities and things like that. Now, are there any questions about that? So your reading quizzes you have to do. The extra credit you do not have to do. Any questions
So if
about
I get
that?
So if I get to 503 before the final, I don't have to take the final?
That's right. Now, one more caveat I need to tell you about. In Pearson, there's a sync issue that in these with these assignments, these extra credit, because they're set as 0, they're not pulling over, so I have to manually bring them over. I'm going to go in and make them worth some points so they will actually come over and sync correctly in the grade book. But I'm going to add in the full grade center, I'm going to add you're going to see some columns like RQ total, and I'm going to start summing up so you see what you have for your actual total, your points, and what you have as extra credit, okay? So don't worry about that, but I will sum everything up, and I'll let you know if you've reached those points the week before the final, okay? And probably a little bit before. So what I'm saying is I don't have there's some problems with that sync, and so I have to do some manual calculations to make sure, so you'll see some extra columns in the grading column, all right? But the class is based on points, you know, and you can work on your quizzes early. You can work ahead on all your quizzes.
Will that hurt us?
It won't hurt you a bit. You want can anybody remember what I recommend for how to be successful in the course? Like the sequence of what you should do? So you can see the schedule and the syllabus. I've got that posted. You can download the syllabus. I've got a grade calculator. The first thing you need to do next week, you need to read, chapters 1 and 2, and then you're going to go out and read the chapter, okay? Then I want you to go to your study area, and I want you to do the end of the chapter practice quiz. So you go to your study area, and you're going to study by chapter, and you can actually go here because you can start right here. You can go to your ebook, read the chapter. If you want any extra, watch a video or smart figure here, then go to your practice, end of the chapter quiz. Which one of the following is not part of physical geology? Rocks, minerals, mountains, stars, or earthquakes? What say you? Physical geology. Show your hint. Don't space out so we know it's stars. And this is interactive. It'll tell you what's right. It'll tell you what's wrong. There's about 15 of them. So you can go through this. And so which one of the following is not part of ocean basins? Continental slope, abyssal plain. Oh, craton, that's right. You can see your results. It'll tell you how many you got right. That's your practice quiz, and that's your study guide. After you've done that, then go back and take your regular quiz.
And then do the questions we see on the practice quiz show up on the regular quiz?
Sometimes. Sometimes they do. Sometimes I do use some of those end of the chapter. But if you do the end of the chapter, they kind of cover everything. Then you're able to go take your regular reading quiz. Okay?
So there's only one quiz we're supposed to take with each chapter, correct? That's where I got confused the other day. I thought there was 2 instead of just 1.
There are. Sometimes I couple them. And so right here it'll say reading quiz 1, read chapter 1 and 2. Reading quiz
Okay.
2 is over chapter 2 and 3. Reading quiz 3, 4. Some of them I had to double up. So when you look at
Okay.
the assignments, and I'll go back over that because I caught something yesterday, but maybe I should put that over here for you and tell you what chapters it's over, so it'll help you a little bit in the syllabus. I'll go through and do that so you know,
Okay.
because sometimes it does double up. I mean, that, you know what I mean? Like reading quiz 8's over 3 chapters. So I'll over here, I'll put that in there for you so it's clear. I did in most all of them. I'll fix 9. But quiz, I put what chapters it's over.
Okay, and then we get till next Thursday to complete that?
Yeah, it's due at Thursday night at 11:59 for RQ1. And then I'll tell you the first quiz is going to allow 2 takes, but after that you get 1 take, but I'm giving you the number of attempts per question is 2, okay? So make note of that on reading quiz 1, I'm letting you have 2 attempts, all right? But after that, you'll only have 1 attempt. So reading
you.
quiz 1, you get to take it 2 times and do the best score. I guess we went a minute past, and so I'm gonna stop now, you guys. We got through most of it, and I can finish these real quick next time. But are there any other questions about being successful in the course? Is there anything that's not clear to you?
I have a question.
Okay.
All right, so like if we're to look at our quizzes and tests for the chapter, it says we have 95 to 115 minutes. So are they timed?
No, they are not timed. What happens on those, and that's a great question, they are not timed. And so what happens is, like, when I select the questions, let me find that. And if you guys need to go, if you've got another class, feel free. But when I select the questions, so for example, I'll show you what happens. This is, can you see this? Can you see my screen where it says edit assignment?
Yes.
Okay, what happens is I go down and I say, okay, this is going to be coming out of chapter 1. I try to use multiple choice questions because I don't like anything else. So I go down, and so for chapter 1, oceanography is the study of the oceans and the geology is the study of Earth, so what's meteorology? I selected that. That's one of your questions on the quiz, okay? And it tells me how much time it takes over on the right. You see that? The time. It means it's going to take that much time, but the person, like the person that designed this, that's what they're telling me as the instructor is the estimated time. So here's the quiz. There's 38 questions in that, and when you sum it up, the estimated time is 101 minutes. It's not going to take you 101 minutes if you have a good internet connection, okay? So I've got lots of, they're not always 38 questions, but then I divide them all up so you're getting 20 points. But that's an estimate. So there's one in there dealing with numbers that's 15 minutes, and there's a Google Earth. Now let me tell you, that Google Earth is only worth 2 points. One fella asked me yesterday, he said, my computer, I can't download Google Earth Pro. It's free. I said, man, don't worry about it. If that's an issue that you've got a slow computer, like I'll give you the points back in a different way and sit down with you. I want you to know how to use Google Earth Pro, but it's like 2 points. So don't stress it, okay? I have enough bonus points out there. If your computer can't handle downloading Google Earth Pro to finish that, then you can make it up by just going and doing a dynamic study module too. You know what I'm saying? And this first quiz, it's got several questions, okay? Most of the time I don't have that many questions, but I'm giving you 2 takes. I'm just trying to get everybody fired up and everybody started, okay? Then I set the due date. It's also available to you right now. And you only lose 1% per day. So if you forget to take it Thursday night, don't stroke out. Take it on Friday, okay?
All right, so when I go to open that test, I don't have to worry about having to have it done in that 95 to 115 minutes.
No, that is not time at all.
Okay.
But that's a great question. No, you've got all the time you want to do it. You have 2 times to do it. You lose 1% per day.
You get 2 tries per question, and I don't have a time limit on it. You can print it, and you can cut and paste it and put it into Word, but there's no time limit.
Okay.
Any other questions? We went over time a little bit, but I want to make sure everybody knows how to be successful. And you just kind of get into a groove with this course, you know, and I'll put out there what chapters that it's over, just to make sure we're clear on that. And so every week, you know, you can just stay in here, go into Pearson My Mastering, read the chapter, do the end of the chapter in your study area, and then go to Mastering Assignments and take the quiz, okay? I have to sync this manually. You will see the reading quizzes grades come over. I have to go like this, refresh the grades, and I have to tell it submit, and I'll do that Sunday night. And so then your grade will post in your grade book, and then you can go to your grades and then see those grades, okay?
And now is the final
What?
is the final made up of the chapter tests, or how do you have your final made?
Yeah, it's going to be about 80% of the reading quizzes. I'm going to have some of the practice in there, the end of chapter practice, and it'll be mostly the reading quizzes. That's exactly what I do. Now, I will tell you, I'll use the question and the right answer, but I may not use the same wrong answers. You know what I mean?
Yeah, you're mix up the options.
Yep. But I will have the question and the right answer. But I may not have the wrong answer. I may not use their wrong answers. You know what I'm saying?
Mm-hmm.
And I won't be all, though the midterm and the final, there won't be any of this matching business. It'll all be multiple choice. So here's an end of chapter quiz in chapter 1 in your quiz right now. So I may ask, how old is Earth? And I may put 4.6 billion years at the bottom, and I may, you know, switch these all around. You know what I'm saying? I don't use their wrong answers, but I do use their right answer.
All right.
And then when you study this, you highlight the right answer. And from the student view, I give you the option to print it, and I suggest that you print it, and you keep it as a study guide as well. Okay?
All right.
And then you go through it and you highlight. So, you know, minerals are natural occurring inorganic solids, and you highlight the correct answer. So I suggest that you print that. And I
Now,
tell
you
you,
gave
man,
us-
what?
You gave us 2 attempts on the first quiz. Do you have like a pool of questions you pulled out of, and like, let's say we get an 80 on the first time, and then we go to take it the second time, you have a separate pool of questions on that second quiz?
No, it's same thing.
Okay.
No, it's the same thing. And that's why as we go forward, I just give one try because, you know, I had one kid in 2 weeks, he did every quiz with the 2 tries. So he just took it, wrote down the answers, you know what I mean? So that, you know, that's not my intent. So reading quiz 2 forward, you just have one try.
Alrighty.
And you can have your book open while you take it in another tab. And on the e-text, it has a search feature. So we go back to Pearson My Lab, and we went over. So I mean, you know, if you guys need to go do something else, I don't want to hold you up from another class. But when you go in the e-text, I do use the search feature. It's very helpful. And I use the phone app. I haven't tried the search on the phone app, but you can even open your book on the Pearson app on your book or your tablet. But up here, you can bookmark. You've got a bookmark. You can highlight. You know, the book is interactive, and like you can look up biology, and it'll give you all the occurrences of biology in the book, and then you can click and go to that section. And the search feature, let's see, stars. You can look up phrases. You know what I mean? So that search feature is really useful.
mean, the book's really good, the ebook. And I know some people prefer a physical copy, but for this class, you could use this ebook because it works great. Any other questions, you guys? We've only got 1, 2, 3, 4, 5 of you in here. Ari, DeAndre, Mason, Robert, Sean. And I don't worry about taking attendance so much because it'll create a report and tell me who was in the room and what time and how long. Any other questions?
I don't have any.
Okay, is there anything else? I'm going to stop the recording.